الرجيم بسم الله الرحمن الرحيم ملګرو نن به چې کوم دی مونږه Avogadro's law باندې ډسکشن کوو کلاس فرست کیمستري نه چې کوم دی د ملګرو ډیماند و چې مونږ ته Avogadro's law باندې لیکچر راغلی. Let's we go toward the topics and the topic name is Avogadro's law. So we will try to understand with the easy concept, with the easy way. That's inshallah there will be no difficulties to your people in this after the completion of this lecture. So we start the lecture and the name of the lecture in this video is Avogadro's law. Students, what is Avogadro's law? What is the statements of Avogadro's law? So let's we write first of all the statements of Avogadro's law. So how can we write the statements of Avogadro's law? So students, it's so simple. Equal volume of gases contain equal volume of gas contain equal number of particles. Equal number of particles at constant temperature and pressure. Students, this is the statements of Avogadro's law. If someone asks from you, please describe me the statements of Avogadro's law. So then words will be answered. So at that time you can say to him, the statement of Avogadro's law is just like this. Equal volume of gas contain equal number of particles at constant temperature and pressure. This means if we keep the temperature constant and pressure, and when we put any gas to a cylinder, it will contain equal number of particles. If you put a hydrogen gas in a cylinder or any other gas so it will contain the equal number of particles. But the mass of each gas will be different, but the number of mole will remain same. So let's explain a little bit, and we also derive the mathematical forms of Avogadro's law. So how can we derive the mathematical form? So it's so simple, mathematicals. Students, if this question come on paper, so how you will derive the mathematical form for this law? So it's so simple. If you learn the definition, if you learn the statements of Avogadro's law, then you will be able to derive the mathematical form of it. So how can you do? Look at volume of given mass of a gas is directly proportional to number of mole. Mean that if you increase the number of mole, then the volume will also become increased. If you decrease the number of mole, the volume will also decrease at that factor. But the condition must be satisfied. The condition for this condition will be satisfied in this case when we keep the temperature and pressure constant. If we disturb any of these two factors, then there will be no direct relationship between volume and number of mole. So student, keep in mind, if we keep the temperature and pressure constants, so then there is a direct relationship between volume and number of mole. Means that if we increase the number of mole, then the volume will also increase. If you decrease the number of mole, the volume will also decrease at that factor. And how factor you decrease the number of mole, at that factor volume will also be decreased. So here we know that when we remove the proportional sign, we put the constant instead of proportional sign. So how can we write this equation? We can write this equation is equal to, here will be put constant and the name of the constant is K and there is N. Clear, students? So now we derived the value of constant, so both side will be divided by n. N will represent the number of mole, and n will cancel out each other. So there will remain with us k is equal to v divided by n. So this is the mathematical form of Avogadro's law for the gases. Students, if we take the ratio of volume to number of mole, so their ratio will remain constant in each case. So this is the mathematical form of the Avogadro's law. So if someone asks from you about the unit of K for the Avogadro's law, so you can say at the time the unit for K, the unit for the unit of K, unit of unit of K for Avogadro's law. Avogadro's law. It's the most important uh, things you should note it in your minds, and it should be never forgotten from your minds. So how can we write the unit for it? So K is equal to V divided by N. We already know that the unit for V is a decimeter cube, and the unit for N is a N is a unit for the amount of substance. So what will be the units of K? So you can say the times the unit for K for the Avogadro's law is decimeter cube per mole. So this will be the units for K. Students, let's explain a little bit this law. Let's suppose if I take 1 mole of hydrogen gas, if I take 1 mole of hydrogen gas, it will occupy to 22.4 decimeter cube volume, and it will contain Avogadro's number, and it will be equal to, it will also equal to 2 grams. Sorry, it will write just like this. 1 mole of hydrogen gas contain 2 gram. 2 gram contain occupy 222.4 decimeter cube volume, and it's also equal to it will contain a Avogadro's number. It is also equal to 22,400 centimeter cube. It is also equal to 2244 liter. Yes, students, if I take 1 mole of hydrogen gas, so 1 mole hydrogen is made 2 gram of hydrogen gas. If we put the 1 mole of hydrogen gas to any cylinder, it will occupy 22.4 decimeter cube volume, and it will contain how many hydrogen molecules? So there will be a greater number of hydrogen molecules, and it also equal to 22.4 decimeter cube, also equal to 22,400 centimeter cube, and also equal to 22,4 liters. Dear students, let's become next example. If someone asks from you, if I take 2 mole of hydrogen gas, so then what will be the volume of that gas? So at that time you can say that 2 mole of hydrogen will occupy 44.8 decimeter cube volume, and it will contain 2 multiplied by Avogadro's number of. Here look at, when we increase the number of mole, the volume will also increase at that factor. Here I increase the number of mole, so volume will also become double. If I decrease this factor, the volume will also be decreased. Let's suppose if someone asks from you, if I take 0.5 mole of hydrogen gas off, if I take 0.5 mole of hydrogen gas off, so what will be the volume for it? So I write 1 per 1 mole of hydrogen gas or per 1 mole of hydrogen gas, or there is a 22.4 decimeter cube of. If I take 1 mole of hydrogen gas, it will occupy 22.4 decimeter cube. And someone asks from you, if I take 0.5 mole of hydrogen gas, so how many volume will be occupied by it? So you can set the time. It will also become, if this factor become half, it will also become half. So it will become 11.2 decimeter cube. So this is the proof of this equation. So when we increase the number of mole, the number of volume will also become doubles. If we decrease the number of mole, the volume will also become decreased at that factor. So this is the example. Let's come toward the next example that we will be able to understand. If someone asks from you, if I take 3 mole of hydrogen gas off, if I take 3 mole of hydrogen gas off, so how many volume will occupied by 3 mole of hydrogen gas? At that time you can say that we know that 1 mole of hydrogen gas occupied 22.4 decimeter cube. So, how many volume will occupied by 3 mole of hydrogen gas? So, you can say that just only multiply this term. And so, give us a few people. So, let's say multiply 3.22.4 decimeter cube. So, it will become just like this. That will become 67.2 decimeter cube. If I take 3 mole of hydrogen gas, it will occupy 67.2 decimeter cube. It means that so if we increase the number of moles, then the volume will also become double. That's the volume will also be double. Clear, students? Let's come the next example. In the next example is for the oxygen atom. 1 mole. If I take 1 mole oxygen, if I take 1 mole of oxygen, it will be equal to 32 gram. 32 gram. It will occupy 22.4 decimeter cube volume. It will contain Avogadro's number. If I take 1 mole of oxygen, it will contain 32 gram. 32 gram occupy 22.4 decimeter cube volume and will contain how many oxygen molecules? It will contain a greatest number of molecules. Here I written other statements. Equal volume of gas contain equal number of particles at constant temperature and pressure. If we take any gas of 1 mole, it will contain, it will occupy the same volume. If you take 1 mole of hydrogen gas, it will occupy 22.4 decimeter cube volume. If you take 1 mole oxygen gas, it will occupy 22.4 decimeter cube volume. If you take 1 mole sulfur dioxide gas, it will occupy 22.4 decimeter cube. The procedure will be same for the all gases. If you take any one of 1 mole gas, it will occupy the same volume. So that was the simple logics which will be discussed. Next we come. If I take 1 mole of sulfur dioxide gas, if I take students, another example of discussion is if I take 1 mole of sulfur dioxide gas, it will contain if someone asks from you what does it mean by 1 mole of sulfur dioxide gas, it means that if you take 64 gram, it means that 64 gram sulfur dioxide gas, it will occupy 22.4 kg volume and it will contain Avogadro's number. I already said to you, if you take any type of gas, 1 mole, it will occupy the same volume. So look at here. I take 1 mole oxygen, it occupies this 22.4 decimeter cube volume. If I take 1 mole sulfur dioxide gas, it will also occupy 22.4 decimeter cube, and it will contain the same particle. Clear, students? So let's become the next example. Uh, we will discuss. But there is also another statement I would like to written here. Equal, 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 equal volume, equal volume, equal volume of gas contain equal volume sorry, I have been written double. Equal volume of gas contain equal number of particle but equal number of particle will be same. Equal number of mole contain equal number of particle, equal number and equal number of mole but different different masses. Remember, this is the most important sentence for your people. From exam point of view, if someone asks from you if equal volume contain equal number of particles, as I mentioned here, particle and equal number of mole, the mole will also be same, but different masses. What does it mean by the statements? Let's suppose here I want to draw a few containers for the understanding of this sentence. Let's we take 3 containers and we fill these up 3 containers from the different gases. Here I put here I put 1 mole hydrogen gas, and here I put 1 mole oxygen gas, and here I put 1 mole nitrogen gas. So it will contain these are the three containers, and each of which are filled with the different gases. So each of these container will occupy 22.4 decimeter cube. It will also occupy 22.4 decimeter cube. It will also occupy 22.4 decimeter cube. And it will also contain 6.023 into 10 power 23 particle. It will also contain 6.023 into 10 power 23. It will also contain 6.023 into 10 power 23. Look at equal volume of gas or equal volume of gas or contain equal number of particle, and equal number of mole. It's will hydrogen is 1 mole, oxygen is also 1 mole, nitrogen is also 1 mole. So mean that if we take any gas of 1 mole.